Okay, hi. Today I will talk about the soil improvement, which is we will talk about the Electro Osmosis Method. This is for assignment 2 Foundation Engineering BFC 43103, and my name is Siti Qastina binti Subarman with the metric number of AF190207. Soil improvement is an alternative considered when the natural soil does not meet the engineering requirement for a project. Water can have an important influence on stability of soil. The strength and stability of soil are dependent on the effective stress, and hence they are directly related to the change in the pore water pressure. Dewatering is a technique of improving soil behavior by reducing pore water pressure and water content. Electro Osmosis Method. When a direct current is applied to a porous medium saturated with water, the water moves towards the negative electrode, which is cathode. This phenomenon is termed electroosmosis. Electroosmosis is used during dewatering to facilitate the movement of water. It accelerates the movement of water through the soil into an installed drain or well pond. The applicable soil type for this method from Esteban Nasir and Javadi, they said the use of electroosmosis for treatment of soft clay soil is a common ground improvement technique, while Martin Alizadeh and Megoda 2019 said that electroosmosis is an established method of dewatering fine soil, sediment and sludge. So, the advantage of using electroosmosis method is first, it can accelerate the consolidation and strengthen the soft saturated clay soil. Second, it has a potential to overcome the limitation of very slow and in some cases effectively zero hydraulic flow in fine grained, low permeability materials such as silt and clays. And the third, it can result in flow rate 100 to 1000 times greater than hydraulic flow in fine grained materials. And this is the material used or equipment used for this method of electroosmosis method. For the procedure for this method, first, a specific amount of air-dried soil was mixed with water to achieve a water content of 5% above the limit liquid. And second, the soil was mixed by the hand still for about 1 hour until a smooth condition was achieved. And third, this mixture was kept in a plastic bowl with closed lid for about 10 days for uniform distribution of water content. And fourth, the next step, the strength of the prepared soil was measured by using shield vent apparatus in random points of the soil. So the prepared soil sample was placed in the main cell and a saturated geomembrane was placed on top of the soil to create a horizontal flow condition. After that, the level of the water was kept the same in the anode and cathode reservoir at two sides of soil in the main cell. For the next procedure, then a surcharge pressure of 32 kPa was applied to the soil via the loading plate. After that, the settlement of the sample was monitored using a dive gauge. The consolidation settlement stopped after about 5 days, and this stage of test will be referred to as preloading consolidation. And when this stage was complete, a number of samples were taken along the soil for determining the water content. So the osmosis consolidation was carried out after the preloading consolidation stage by setting the hydraulic gradient between two reservoirs to 0. And then the osmotic consolidation was enforced by applying a DC current through the soil. The vertical deformation was measured by monitoring the reading of the dial gauge, and the volume of the sample was calculated by measuring the volume of outflow water from the cathode reservoir during the test. So the total time for consolidation stage was about 10 days for different voltage. And lastly, after the test, the undrained shear strength was measured during shear vent at the anode, middle and cathode, and a number of samples were taken for determination of water content and outer back limit. Thank you.